All right, let's look at question 7 here. So we're given a graph of a function, but one thing I want to be very clear on is that this is not a graph of g. So we're talking about a function g. The graph we are looking at is not a graph of function g, it's a graph of g prime. So that's going to be a very important thing to keep in mind as we work through this. So part A, what is the approximate slope of the tangent line to y equals g of x at the point to g of 2? So we're being asked about the slope of the tangent line. So what is the thing that tells us the slope of a tangent line at a point? That comes from the derivative of the function you're asking about. We're asking about the function g, so this information is going to come from the derivative of g, or g prime. So we're being asked about g prime of 2. So this question is maybe deceptively simple. We don't need to think about the tangent lines of this graph. We need to simply look at the values of the points on this graph. So g of 2, g prime of 2 is going to come from the y value of this point here. So I would estimate that as, I think we can say 1.5, 1.5. So again, I suspect that many of you are probably thinking, all right, I want the slope of a tangent line. I'm going to try to make a tangent line at this point and calculate its slope. But keep in mind what this graph is. This graph is g prime. So if you want g prime of 2, you're simply reading the point. Which reading the point is not the difficult thing here. It's understanding why that is what you need to do. So moving on to part B, how many real number solutions can there be to the equation g of x equals 0? Justify your conclusion fully and carefully by explaining what you know about the graph. All right. So how many real number solutions can there be to g of x equals 0? So basically, I need to heavily emphasize that what I am drawing on the right here may or may not, it's not, I'm not saying that it's a graph of g, but basically I'm just trying to illustrate what the question's asking. This is the x-axis, this is the g of x-axis. Basically, I'm looking for this. How many x-intercepts do I have? Okay, so again, knowing that this is a graph of g prime, notice that g prime is always positive. So what does that mean? So g prime of x is positive for all x, at least all the x that we can see. What does that mean? Well, that means that g is increasing for all x. If we have a function that's always increasing, I think now I can safely say that our function g does not have a graph that looks like this. Our function g has to have a graph that looks like this. It has to be, it's not linear. I'm not going to say that it's always increasing at an increasing rate or the same rate, but it's always increasing. So because of that, I think that means that, how many solutions can I have for g of x equals 0? I think it could be 1, because if it's always increasing, it might cross the x-axis. But there's also the possibility that maybe this graph is entirely above the x-axis, which means it can never cross the x-axis. So those are my two possibilities: 0 solutions or 1 solution. Hopefully, the way I've explained this has convinced you that it's impossible for there to be more than 1 solution. So there's at most 1. Moving on to part C. On the interval, how many times does the concavity of G change? Okay, so now we're giving more specifics. We're just looking from x equals -3 to x equals +3. How many times does the concavity of G change? So let's ask ourselves, or remind ourselves, what is it that tells us about the concavity of G? The concavity of G is some information I can get from the second derivative of G. So basically, I am looking for where does G double prime do one of these things? Go from negative to positive, or where does it go from positive to negative? So that's the question. How do I get that from this graph, again, which is G prime of X? Well, what does it mean if G double prime is negative? So let's make a little table here. Or let's just write some ideas out. If G double prime is negative, what does that mean about G prime? That means that G prime is decreasing. And similar idea, what does it mean if G double prime is positive? That means that G prime is increasing. And let's go ahead and let's unite all three of these functions here. The function G, its first derivative and its second derivative. If G double prime is zero, or sorry, is less than zero, that means that G prime is decreasing. That also means that G is doing what? G is concave down. Just like G double prime being positive means that G is concave up. So the question we were asked is, where does the concavity change? So we're looking at a graph of G prime. Where does the concavity change? Where does it go from down to up or up to down? Well, it's wherever the graph of G prime goes from decreasing to increasing, or vice versa. So where does this graph go from increasing to decreasing? That's going to take place anywhere we see a maximum or a minimum. So let's just circle all the places. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this last point's going to be a little bit beyond x equals 3. So I believe, and hopefully you're okay with my reasoning, that 1, 2, 3, 4, 5, 6, 7, 8, 9. There are nine times where this happens on the interval we care about. All right, moving on to part D. Use the provided graph to estimate the value of G double prime of 2. All right. So we want to know the value of G double prime of 2. So we know what G prime looks like. That's the only thing we have a really good idea on is what G prime is doing all the time. How is G double prime related to G prime? Remember, the derivative of a function always tells you its instantaneous rate of change. So what is G double prime the derivative of? G double prime is the first derivative of the first derivative. So it's the first derivative of G prime. So what I'm being asked for here, G double prime of 2 is, what's the right, let me make sure I know the right way to word this. G double prime of 2 is the instantaneous rate of change of G prime of X at X equals 2. How do I find the instantaneous rate of change of G prime of X at X equals 2? Well, I have a graph of G prime. The instantaneous rate of change, the way that that's represented on the graph is through the slope of a tangent line. So let me try to make a tangent line at this location. So again, this is an estimate. I'm not promising that my tangent line will, A, it will not look exactly like yours, and B, I'm not pretending or promising it's going to be correct, but let's estimate the slope that I've just drawn here. Looks like this goes, from this point up to the top here. I think in the span of one horizontal unit, how far upward do I go? 1, 2, 3.5 vertical units. So I'm gonna say a good estimate for G double prime of 2 is either 3.5 or 7/2, whatever you prefer. But again, so it's just an estimate. I just hand drew a tangent line on a graph. And if you did the same thing, it's very likely that we're going to be different by a little bit. Um, so I would say that clearly, or I shouldn't say clearly, but I think at a minimum, your answer needs to be a positive number. The slope of a tangent line at that point needs to be positive, and it looks pretty steep. I think it needs to be greater than one. Right.